factor theorem. So in this theorem, before saying this factor theorem, let us see the one small example. We know 2 into 6 is equals to 12, right? That means 2 is a factor of 12 and 6 is also a factor of the 12, right? 8 into 4, so 32. In this means 8 is a factor of 32, 4 is also a factor of 32. If 8 is a factor of 32 means take 32 and divide by 8, you'll get the remainder 0. So take 32 divide by 8, remainder 0 will get. If 2 is a factor of the 12, now 12 divided by 2, you'll get remainder is 0. That means if you divide with any factor, the remainder should get 0. So same concept will apply in this polynomial. When polynomial f of x is divided by x minus a, then remainder is f of a. We discussed previous. And if remainder is 0, in case if f of a is equal to 0, then this x minus a is a factor of the polynomial. The remainder is 0, that x minus a, that factor, this word, this polynomial or this expression is a factor of the polynomial. So same thing we'll use. Remainder theorem we are applying that remainder if it is 0, then x minus a is a factor of the polynomial. Let us see here. First question, determine whether x minus 1 is a factor of this polynomial or not. So remainder should get 0. Here is the given question. X minus 1, you first make equal to 0. From this x value find out is 1. Right? X minus, remainder is f of a. If x minus a is divided by x minus a, then remainder is f of a. If it is divided by x minus 1, then remainder is f of 1. X is equal to 1 we got. So this is the function. When the given polynomial is divided by x minus 1, the remainder f of 1. Wherever x is there, 1 we can substitute. X power 6. So 1 power 6 minus 1 to the power 5 plus 1 to the power 4 plus 1 cube minus 1 square minus 1 plus 1. This value 1 to the power 6 is 1 minus 1 plus 1 plus 1 minus 1 minus 1 plus 1. Cancel this plus 1 minus 1 minus 1 plus 1 minus 1 plus 1. Still 1 is there. So this is non-zero. It's not equal to 0. That means x minus 1 is not a factor of this. So it's not factor. As per the factor theorem, if x minus a is factor, because remainder is 0, then only x minus is a factor. So remainder is not 0. Therefore x minus 1 is not a factor. Let us see the concepts in this more. Here's the question. Find the value of k if x minus 2 is a factor of x cube plus 2x square minus kx plus 10. They mentioned already x minus 2 is a factor of this function. So since it is already factor, so as per this factor theorem, remainder must be 0. So here's a given expression f of x cube plus 2x square minus kx plus 10. Right? Again, x minus 2 is a factor. Since x minus 2 is a factor, and let x minus 2 is equal to 0, then x is equals to 2. And that means f of 2 must be 0. Then f of 2. This value should be equal to 0 because as per the factor theorem, because x minus 2 is already factored, so remainder must be 0. Wherever 2 is there, you can substitute in this. So 2 cube plus 2 into 2 square minus k into 2 plus 10 is equal to 0. Let us simplify from here. 2 to the power 3, 8. Next one, plus 2 square is 4, 4 2 is 8. Minus 2k plus 10 is equal to 0. Right? 8 plus 8, 16 plus 10, 26. So minus 2k is equal to minus 26, take other side. Then k is equals to 13. Minus minus cancel, 26 by 2. So k value is 13 now. Now on substituting this k is equal to 13 in the given expression. So then it becomes, then f of x becomes x cube plus 2x square minus kx, right? K is 13. So 13x plus 10. Now the question is determine whether x plus 5 is also a factor. Determine whether x plus 5 is also a factor. So x plus 5 is mentioned. So that is, since x plus 5 is equal to 0 you take, then x is equals to minus 5. In the place of x, minus 5 is supposed to substitute. So f of minus 5 value, x cube. So minus 5 whole cube plus 2 into minus 5 whole square minus 13 into minus 5 plus 10. If this value is 0, then x plus 5 is also a factor, because as per this factor theorem. Minus 5 whole to the power cube, so minus 125. Minus 5 whole square is 25. 25 2s are 50. Minus 2 minus plus 13. 5 is 65 plus 10. Minus 125 plus 50 plus 65 plus 10. So 125. Minus 125 plus 125 is 0. So since the remainder is 0, x plus 5 is a factor. So whenever they are asking is the only factor, the remainder is 0. If the remainder is 0, that is where is the factor. Let us see the one more sum in this type. Same function or single polynomial with two conditions, how to solve. Here is the question. Polynomial x cube minus ax square plus bx minus 6 leaves the remainder minus 8 when divided by x minus 1, and x minus 2 is a factor of it. So till here is one line. Leaves remainder minus 8 when divided by x minus 1. Right? Let us take two equations. First one, f of x. X cube minus ax square plus bx minus 6. They mentioned it is divided by x minus 1. Right? Let x minus 1 is equal to 0, then x is equal to plus 1. Right? So already mentioned remainder is minus 8. So when you substitute f of 1, the result should be equal to minus 8. So here's 1 cube minus a into 1 square plus b into 1 minus 6. This value you can simplify now. So finally we'll get 1 cube is 1 minus a plus b minus 6 is equals to minus 8. Then minus a plus b is equals to 1 minus 6 minus 5, take right side, minus 3. Then if you multiply with minus both the sides, minus a becomes plus a, minus b is equal to 3. Even you can stop here, you can make into positive term of the first term. Right, is equation 1. Now, and x minus 2 is a factor. X minus 2 is a factor of it. So if since x minus 2 is a factor, as per the factor theorem, then x is equals to 2. So f of 2 is equal to 0. So f of x value 2, right? So f of 2 must be 0. Let us substitute 2 in this. Wherever x is a 2, we can substitute x cube. So 2 cube minus a into 2 square plus b into 2 minus 6 is equal to 0. Because only factor, right? 8 minus 4a plus 2b minus 6 is equal to 0. Then finally a term, b term take other side. Okay, or else minus 4a plus 2b is equals to 8 minus 6 is 2, it becomes minus 2. Take minus 2 common, it becomes 2a minus b is equals to 1. Take minus 2 common both the sides. This is equation 2. Right. On solving equation 1 and 2, you'll get a and b values. Just to do elimination method, so you'll get finally a is equals to minus 2 and b is equals to minus 5. Elimination method you apply. Just we did previous. Same concept you can apply. Minus b. Now you can subtract. So by elimination method or solving equation 1 and 2, will get a is equals to minus 2 and b is minus 5. So this is the way we can solve the problems even from factor theorem. Now let us see how to use the factor theorem to factorize the given polynomial completely.